Base metals. It's all about those base metals. So we're going to talk about just 3 examples of base metals. There's a whole bunch of them out there, but I wanted to talk about 3 kind of fairly important ones. Remember that the definition of a base metal is something that is fairly scarce. It's not necessarily incredibly valuable, although they definitely have value. They're not in the precious metals realm. And I mentioned a kind of wonky thing in the beginning about not having a chemical affinity for iron, meaning they're not in the +3 oxidation state. Don't worry about that. But it means that they don't jive well with iron, but they have uses on their own, and they are important on their own. So this is also going to allow us to talk about kind of how some things like alloys work when we get a little bit further along. So like I said, we're just going to highlight 3 different metals that fall into this category. The first one we're going to talk about is copper. So copper is what's considered a base metal. For those of you who are students of human history, kind of especially prehistory, human history, if we think about kind of the general terms that anthropologists use to define these times, they're really all about the technology of the time, right? So we've got the Paleolithic, which is the old. Paleo means old, lithic means stone, the Paleolithic. We've got the Neolithic, which is neo means new, lithic still means stone. So the old Stone Age, the new Stone Age, and then after the Neolithic, we enter into what we call the Bronze Age. Well, bronze isn't a metal on its own, so we're going to talk about kind of what that is in a second. But copper is going to fit right into that discussion. So copper occurs in a couple of different types of minerals. Vibrant green mineral is known as malachite, which is copper carbonate. Copper carbonate, 1 part copper, 1 part carbon, 3 parts oxygen. Actually, we call this little guy right here a carbonate. So it's a copper carbonate. Pretty straightforward. So that's malachite. There's some others that are actually kind of used more commonly in the modern world. You can see this is a rock known as chalcopyrite, which is also serves as a copper ore. With copper, and particularly with malachite, getting the raw metal off of the rest of the mineral, that's going to be the challenge that we're going to need to overcome, right? And I'm going to pick on malachite specifically because it's easy to kind of have this discussion. So what we need to do is we need to figure out how to break the chemical bond here, get our copper, or our carbonate ion, and our copper, our free copper, which will head off the other direction. And we've actually already seen that notion. But here we're going to introduce kind of how to do that. And it turns out the amount of energy required to separate these things kind of has determined where they show up in human history. So taking malachite, which is a really pretty green rock, presumably people had hanging around, right? Because you can make all kinds of stuff out of malachite, pigments and things like that. And one of the things that's really interesting is if you take powdered malachite and you throw it in a campfire, it changes the colors of the flames. It's really bright green. That has to do with some other physical properties or chemical properties, But presumably, this is kind of guessing to the history and the origin of this, presumably people would do that, right? You'd have little tiny bits of malachite, you could throw it in the fire and change the color, and you didn't have iPhones to entertain you, like, woo, the fire changed color, that was the big entertainment of the night. But what happened in that case is it turns out you're introducing carbon into the system because you're burning wood, right? So charcoal. And there's enough energy here that this bond starts to weaken. So I wanted just to clean this up a little bit. As we start to heat this up, we'll actually drive off a carbon dioxide. So we're left with copper oxide, and then this CO2 is left. This bond is fairly strong between the oxygen and the copper because oxygen's a hungry hippo, but its bestie is carbon. So when carbon comes along, if there's enough energy to break this bond, that carbon will actually steal the oxygen and form other CO2 molecules. And what we're left behind with is copper. So those ancients, back, throwing the stuff in the fireplace, when they were to clean the fire out in the morning, what they would potentially find is little copper ingots that were left behind because everything else turns to gas. And actually, we'll watch a video later. This is pretty easy to do, right? So again, the discovery of copper brings us into what we call the Chalcocene, which is a very narrow sliver of time. Basically, you can think about it as the Copper Age, right? Right before the Bronze Age. So again, copper is pretty easy to make. The temperatures required are not that high. The energy, you can do it in a campfire. Geez, you can't do very much smelting in a campfire. That's what we call this process. But aside from that, we use copper for a lot of stuff, right? Copper is famously effective at conducting electrons, right? So we use it for wiring, piping, right? It's really good for heat conduction, right? So you can see here copper pipes. They're fairly soft. That's one of the issues with copper, right? Is that it's really too soft to be all that useful in the context of like making a sword, right? Thinking about our ancestors and all these copper ingots. Probably the first thing they did was tried to make a sword or an arrowhead or something like that, some projectile tip. They used it once, hit a rock with it, it bent, and they said, oh yeah, this stuff isn't that great. So one of the things that makes copper useful to us is that it's so malleable and fairly soft. Makes it pretty useless if you're looking to make implements to help you as tools, right? So especially at that time, the copper ingots largely probably became jewelry or incorporated into how we dress. The next metal that we're going to talk about is tin. We actually used to use tin for all kinds of stuff. I don't really use it all that much anymore. I mean, we do use it for some things. Tin actually comes from a mineral. This is tin ore, cassiterite. You can see this kind of black, silvery stuff. And it has some very similar properties to copper, malachite we were just talking about. It's pretty easy to smelt. So tin lends its name to all kinds of things that probably pop into your mind. Tin foil, tin cans. Here's some beautiful tin foil. Tin foil is made out of aluminum, right? It's not tin. It hasn't been tin for 60 years or 70 years. But tin shares some similar properties with aluminum, except for the weight. So tin is fairly heavy. It's not incredibly heavy, but it feels weighty. Not quite as weighty as lead. If you find real tin foil, it's not lightweight like aluminum foil is. Back before we're really so keen on kind of resource use, we would just take sheets of tin, right? And they're fairly thick, but they would still have some of the same properties that aluminum foil has. Right? Thin enough, it holds its shape and can save your food. Tin cans, again, tin by itself is way too soft. So original tin cans were pretty squishy, and they could get a hole in them fairly easily. A modern tin can is steel, but it actually has a tin coating, or a polished tin coating. So that's one of the characteristics of tin, is it can make a really effective coating that prevents against all sorts of corrosion and things like that. So it does have its uses. But most famously, we're going to go back to our friends in the Neolithic, who are kind of, or I guess they're in the Copper Age, right? Looking to get out of that. Tin is a great way for us to introduce the notion of an alloy. An alloy is a mix of metals, right? So you get metals molten, and you can actually take two different kind of end member elements, right, off the periodic table of elements, and add them together and make a new metal. And the reason why this works, to our advantage, is because the atoms of these different metals are different sizes. So we could imagine atoms of one metal are like marbles, and the others are like BBs, right? So they're different sizes. And actually, if we look here, this is a diagram that kind of highlights how this all works. So if we have Over in the upper left are pure metal, just the little red, the red circles. There's nothing holding that in place, and so that metal will be fairly soft in its pure form. And as we move to the right, we can see that there's an alloy that's added as what we call a substitutional alloy. So it's taking the place of some of those other atoms. And then you can see there's an interstitial alloy. Again, interstitial just means between, where the little green dots are in there. And so basically, if we had our marbles and we started adding BBs in between all of the marbles, and kind of beyond that, we add something even smaller, like sand grains to that, what you would find is that all of a sudden that crystalline structure is going to start to get really rigid or have other characteristics that we're looking for. And so in the bottom right-hand corner, this is what's called the substitutional and interstitial alloy. That naming is meaningless. Basically, a bunch of stuff has mixed in, and all of those atoms are kind of interlocked. So it turns out tin and copper do this exceptionally well. And if you get yourself some cassiterite ore, which we talked about, and some malachite, and you make your copper and you make your tin, when you mix copper and tin together, they form this new metal, bronze. Bring on the Bronze Age. So bronze is much harder than copper and much harder than tin. And it's because those two are mixed together as an alloy. Hopefully you kind of visualize how those atoms work. So now you can make a blade out of bronze. It's actually not going to be that great of a blade comparatively. We'll see. We get better ones later. But you can start to use it for things. There's a wonderful picture of some guys making bronze, right? And you can see they're pouring these molds. So this is all real basic technology that you can actually do in your backyard, right? You can go on Amazon and buy a bunch of malachite. It might cost you 30 or 40 bucks. You can buy some cassiterite, or you can harvest tin from somewhere else in the world, which is not too difficult to do. You can mix them together, make a sand mold of a sword, and you can make yourself a bronze sword on your weekend. You can see here, these are some bronze weapons that are still around, right? So this is the first time we've seen metals made that are strong enough and kind of easily manufactured at low enough temperatures that it kind of brings on its own kind of industrial revolution of a way, right? This kind of metal revolution. And so all of a sudden, you're no longer using stone axes. Now you have bronze stuff everywhere, right? So it's a pretty significant technological advance, a really big moment in human history related to mixing tin and copper together.